Demo survival of Titanic passengers. Problem statement. The Titanic dataset provides information on the fate of the passengers on the Titanic, summarized according to economic status, sex, age, and survival. Our task is to predict the survival of the Titanic passengers. Let us import the required libraries for plotting, model use, and validation, and also the libraries for metrics and reporting. Importing Pandas data frame. Import Pandas as PD. Importing NumPy. Import NumPy as NP. Importing matplotlib libraries. Import matplotlib. Import matplotlib.pyplot as PLT. From pandas.plotting, import scatter_matrix. Importing Seaborn. Import Seaborn as SNS. Importing sklearn libraries for logistic regression. From sklearn.linear_model, import logistics regression. Importing sklearn libraries from train test split. From sklearn.model_selection, import train_test_split. Importing sklearn metrics libraries for confusion matrix. From sklearn.metrics, import confusion_matrix. Importing sklearn metrics libraries for classification report. From sklearn.metrics, import classification_report. Importing sklearn metrics libraries for accuracy score. From sklearn.metrics, import accuracy_score. Importing sklearn metrics libraries for precision score. From sklearn.metrics, import precision_score. Importing sklearn metrics libraries for recall score. From sklearn.metrics, import recall_score. Importing sklearn metrics libraries for F1 score. From sklearn.metrics, import F1_score. Importing warning library to disable Python warnings. Import warnings. Now let's load and read the dataset in Pandas data frame. There are 891 rows in the Titanic data frame along with 12 columns. Using the head parenthesis method to return the top 5 rows of the data frame. We also get an idea of the columns present, like passenger ID, survived, sex, and so on. Let's see which of the columns are required for our analysis. Printing the distinct values in the survived column, we notice there were 342 passengers who survived and 549 passengers who did not survive the crash. Printing the distinct values in the sex column, we notice there were 577 males and 314 females on board the Titanic. Printing the distinct values in the embarked column reveals the count of passengers onboarding from each of the 3 ports that Titanic had docked. 644 passengers boarded from the city of Southampton, 168 from Cherbourg, and 77 from Queenstown. We need to check for missing values as they reduce the quality of our performance metrics. Notice that cabin has almost 80% missing values. We will drop that variable completely. What about age? Age seems like a relevant predictor for survival, right? We'd want to keep the variables, but it has 177 missing values. We need to find a way to approximate those missing values and drop variables that aren't relevant for predicting survival. We should at least keep the following variables. Number survived. This variable is obviously relevant. Number P-class. Does a passenger's class on the boat affect their survivability? Number sex. Could a passenger's gender impact their survival rate? Number age. Does a person's age impact their survival rate? Number SIB-SP. Does the number of relatives on the boat, that are siblings or a spouse, affect a person's survivability? Number PARCH. Does the number of relatives on the boat, that are children or parents, affect a person's survivability? Number fare. Does the fare a person paid affect his survivability? Maybe, let's keep it. Number embarked. Does a person's point of embarkation matter? It depends on how the boat was filled. Let's keep it. A person's name, ticket number, and passenger ID are irrelevant for predicting survivability. And as you recall, the cabin variable is almost all missing values, so we can just drop all of these. Let us build a histogram to visualize the distribution of age. Initializing the histogram. Plotting age. Let's display the plot now. Notice that age is right-skewed, and using the mean might give us biased results by filling in ages that are older than desired. To deal with this, we'll use the median to impute the missing values. Checking the average age per class, we find the average age for first class is 38, for the second class it's around 30, and for third class it's 25. From the above analysis, we could say that the younger a passenger is, the more likely it is for them to be in third class. The older a passenger is, the more likely it is for them to be in first class. We need to deal with the missing values in the age variable. Let us write a function to find each null value in the age variable. We will be assigning values based on the passenger class. Let's go ahead and write the code for the same. For each null value, this function will check the value of the passenger class and assign an age value according to the average age of passengers in that class, replacing null values in the data frame. Let's verify if any null values are present after transformation. There are two null values in the embarked variable which can be dropped. Checking data types of columns, we observe the columns sex and embarked are of categorical data type. Using pd.get_dummies to convert the columns sex and embarked to categorical.